Okay, let's take a look at this. Here's your chapter review for all of your stats. I did send out all the answers for the other stuff, but it's too late to get credit for that stuff, which all of you guys have gotten credit for because you did it all. So let's do this together. 50% probability of a coin landing on heads. Interpret what this probability means. What does that mean? You got 50% heads, chance to have heads, and 50% chance to have tails. That's all it means. Okay? Now, what do you notice in this table here? The joy to the world is missing. What is that?
What thing is it?
Yeah, what should be in that position? How do you find it?
I don't even know where the
I
percent
don't know.
buttoned that up.
This is the stat to be right.
Yep. So this all has to equal 1. So question number 2 is, what is the probability of someone liking joy to the world?
0.4, right?
Well, you add them all up and see how much is missing. Or take 1 minus each of these. So 0.2 and 0.1 is 0.3. That's not 0.5, that's 0.05, so 0.35. And 25, that's going to be 60. So the answer is 0.4, and that's the answer to number 2.
0.4 wrong.
0.4 is the same thing as 0.4, which is the same thing as 0.4,
Oh, no.
which is the same thing as a whole bunch of zeros behind it.
No. I know didn't make it.
Well, that's something students aren't sure of. So there's infinitely many zeros on each end of every number. Okay? What is the probability of someone liking "We Wish You a Merry Christmas"? Or, which means plus, Jolly Old St. Nicholas. So "We Wish You a Merry Christmas" is 0.2. Jolly Old St. Nicholas is 0.1. So 0.3. Or you could say 30%. Either one is correct. We'll just leave them as decimals today. What is the probability of someone not liking "We Wish You a Merry Christmas"? So "We Wish You a Merry Christmas" is 0.2. Not means everything other than that. So 100% minus the 0.2, which would be 0.8. All good? Okay. Now the two-way table here. This is what's difficult because you have multiple things happening at the same time. So let's just kind of go through it. What is the probability of someone driving to school?
75 out of 100.
Yeah, 75 out of the total. 75 out of 100. Or you could say 0.75 or 75%. Okay? Let me write this a little bit smaller. What is the probability of someone being a junior and driving to school?
25 out of 100.
25 out of 100. 0.25. Stop me if you're not sure. You all good? Does this all make sense? You're going to have to answer these questions tomorrow. It's the same as this. It's just not necessarily in the same positions. The numbers are going to be different. Some different questions, but okay. What is the probability of someone riding with a friend or having a parent drive them to school?
90.
Riding with a friend. What'd you say?
I said 90 over.
Who said 23? How'd you get 23, Anthony? Yeah, riding with a friend is 16, and a parent driving to school is 7. So 16, and the or means addition. So 16 over 100 plus 7 over 100. That's 23 hundredths, okay? That should probably... Oops, whoa.
I did that way back.
Let's just blow this up on the screen here. Okay. What is the probability of someone being a junior? Okay, or driving to school. So here we have a problem. Okay, so you have multiple things using multiple things here. You got a junior here. The probability of being a junior is what? 40%. 40 out of 100. You're not saying 75 because that includes seniors, okay? Or means addition. Driving to school. So here's your juniors, and you're driving to school. And there you see the 25 overlaps. You can't count that twice. So the probability of driving to school is 75 out of 100. But you forgot you got to subtract 25 because you counted it twice. And that's the thing you got to be watching for tomorrow. All right, so that's going to be 90 out of 100 or 0.9, okay?
Oh, that's right. I was doing the wrong thing.
Okay, what is the probability of someone being a junior given? Remember, when it says given, only look at that information. Given that they drive to school. So you're only looking, come on, at, oh, whoops. Hold on a second. So you're only looking at the driving to school part, this piece, okay? So now you look at the first part of the sentence. What's the probability of someone being a junior out of that column? 25 out of 75. You use your calculator if you're going to be using decimals, which comes out to 0.3 repeating, okay? What's the probability of someone driving to school given that they, again, given. Now you're just looking at the senior part. So we're only looking at this row. Probability of driving to school that you're a senior. 50 out of 60. And, yep. So 0.83.
Driving to school. I don't get that.
You got to look at your given part. It's talking that you're a senior, so you're only looking at the senior information, which there's only 60 pieces of that, okay? Out of those 60, who drives to school? 50 of them. All right, next page. So now, let's blow this thing up. 65% of newspapers. We're making a diagram here. So right off the bat, you need to draw the first two things. Hard copy and digital copy. So hard and digital. So 65% is the hard copy and 35% is your digital. And then from there you have another branch coming off. You have 7 days of orders versus only weekend orders. So the 7 days is 0.8 and the weekend's 0.2. That's of all the hard copies. And then you have digital customers. Again, 7 days and weekend. Of those digital copies, 90% are for 7 days and 10% are for weekend. So what you should do at this point is just multiply straight across, and 0.65 times 0.8 is 0.52. That would be hard copies 7 days a week. That's how you do that. And it's an and. The probability of choosing hard copies and having it 7 days a week. That's why you're multiplying them to do it, okay? So these are all multiplication. You multiply those out. Here are your multiplication answers if you multiply straight across. What?
How did we get 8?
It's the second sentence. Of the hard copies, 80% are 7 days a week, and 20% are just on the weekend. Okay, so I just went through the tree real quickly, and then you're going to use this information to answer the next set of questions. So if you get the tree diagram wrong, you're probably going to miss a whole bunch of points. What is the probability of a customer ordering a hard copy and, remember, and's the multiplication, 7 days? Getting it for 7 days. That's the 0.52, or 52%. All right. I'm going to stop this for a second, give you a chance to answer those next few questions real quickly, okay? Number 13, what's the probability of a customer ordering a hard copy and only for the weekend?
113.
Yep, 0.13, good job. What's the probability of a customer ordering digital and 7 days?
0.315.
Yep, 0.315 or 31%, 31.5%. What's the probability of a customer ordering digital and weekend?
0.035.
So 3.5%. That's important that you understand the percentages. And then what's the probability of a customer ordering all 7 days? So,
0.335.
no, you got 7 days and 0.8. I'm sorry, your the totals here, 0.52 and 0.315, because you can't have more than one. So all 7 days would include hard copy and digital copies 7 days a week. So 0.52 and the 0.315.
So
0.835. Is that what you said?
Yeah,
Oh.
you said no.
Oh, I thought you said something else. Sorry. All right, then the next one. So again, hard and digital for the weekend is the other 0.13. You could just subtract from one the other one, or you could add these together. What do you get?
0.165.
Yep, so 16.5%. Okay, did you text her?
Yeah, shit.
Okay, let's go to this part. Are the following variables categorical or quantitative? So I'm going to underline a couple things here. Length, type, color, how many. Those, I don't even care what it's saying. Those are keywords that tells you what you're doing. So what does length mean? Quantitative or categorical? Quantitative because it's a value. Quantitative.
Rachel said there's no link.
Oh, I didn't send it?
Apparently not. She said he didn't send anything out.
But I said there was going to be one? Or
Yeah.
I did?
You
I,
did say there was gonna be one.
I did? Oh, that's nice.
Didn't
I
you?
said, okay, hold on.
I saw it on there when I came in.
Yeah.
So the type, quantitative or categorical? Categorical. Color. And how many? Anthony, what's your question? Well, quantitative is the quantity. It means it's a number value that you can get. So you're not going to get a number value about it when you're talking about the type of a pet. We're not asking for how many pets. So we're asking by what type. So that's categorical. You're putting it in a category. Understand? Okay, good. Now fill in the frequency table. All you're doing here to get relative frequency, does anybody remember how?
Wait.
Divide.
Decide.
100 divided by 200 is your relative frequency. Frequency is the actual number. Relative frequency is when you divide the two, okay? So 1 over 2, that's 0.5. What do you get after that?
0.45.
0.8.
And
0.1.
0.11.
it's 0.11. You have to take 10 to divide by 9. Yeah, 1 divided by 9 is 0.11. 2 divided by 9 is 0.223. 3 divided by 9 is 0.33. That's how the 9s work. Okay, let's move on to the next page. All right, now you got to use your handy-dandy calculator. Or just do it by hand. The mean is the average. So how do you find the average?
I roll up and divide by however many you added.
All right, I'm going to stop this. Everybody do that real quickly, and then we'll start up again.
1.5.
The mean is 1.5.
Wait, what? I did something
You add them all together and divide by 22. Did you do that? Yeah, then you just hit a button. Okay. 1.5 is the mean. What'd you get for the median? 2. So you count back and forth until you get to the center, and it's going to be one of the 2s, okay? Does there appear to be any outliers? No, outliers are like really large numbers, which is what number 26 is going to say. If a new student joined the class and they have 15 pets, so you'd put 15 up with that, and it asks, what would that do to the mean?
It would go up.
Yeah, it'd be,
Wait, what is the,
It's where you add it all up and divide by however many you
yeah,
have.
what's the, what did you get when you added it all?
1.5. Oh, when you add it up? I don't know, let's see. 1, 2, 3, 4, 5, 7, 9, 11, 13, 15, 17, 19, 21, 23, 26, 33.
I did
Kendall
22
has
divided by
40.
33. I got
It
26.
should have been 33 divided by 22.
Oh, we got 2 people on there.
He's all
Because you want to take the
Kelsey.
number
Hi.
divided by.
Hey, Trump.
Yeah, I saw you. You're laying around, acting like you're sick.
Lazy hacker.
Okay, so,
Can you hear that? Oh, no.
all right.
26.
Yeah, so if a new student joined the class and they added 15 to it, that's an outlier, so that it would raise the average. And B, what does it do to the median? It stay the same because there's so many 2s that are in the middle that one extra number is not going to change it, okay? And then the standard deviation.
That would go up too, wouldn't
Yeah, it would make it larger.
What's the deviation?
Standard deviation, I'll show you how to, I'll show you here in a minute when we're done, Anthony, how to find it. Okay. Which graph has the higher standard deviation? All right, so this is a crazy graph. Whenever you have graphs that look like this and this, the standard deviation is larger, okay, than a normal graph, than if everything was the same numbers. The problem is, one of these is going to have a larger standard deviation than the other, and here it's the one on the right, because your outlying numbers are bigger than these outlying numbers. So the bigger data, or the more data you have that's spread out, is going to make it have a larger standard deviation. So yeah, both of these will give you larger standard deviations, but this one's going to give you a bigger one than that one. Okay? So when on the 2 on the test tomorrow, you really got to look at the data and see who's going to have more of the data spread out that has, going to create more numbers, bigger numbers and stuff. Okay? All right. What?
I thought that was the bell for.
That's just the first lunch ending. Okay, so the answer is the right one. Let's go down to this next one. Joe wants to find out the average hours of sleep per night for students at Western High School. He randomly chooses 40 students, so randomly choosing 40 students, and asks them how many hours of sleep they typically get. Finds the average GPA for the students to be 7 hours. So what's the population?
All students.
All Western High School students. Sorry, I'm talking loud for the microphone for them. What is the sample then?
The 40 that were randomly selected.
Good, 40 students. Do you expect the average hours of sleep for all students to be exactly 7? No, and the answer should always be never. You should never expect it to be exactly the same as an average, okay, from the sample to the whole population. Do you expect the average hours of sleep for all students to be close to 7?
Yeah.
Yes, and I don't want to say always to that, but I mean in general, if you do everything correctly, it would always be close, okay? So no and yes is all you need for that. Let's go into number 29. Now Joe wants to find out what percentage of students pack their lunch to school. He goes to the commons. Now, this is talking about Western High School here, okay? So he goes to the commons during lunch and surveys 20 people and finds that 85% of them pack their lunch. Why might this percentage be too high for the true percentage of students who pack?
Because that's gonna be the big question.
Yeah, so if you pack your lunch, you're going to typically go straight to the commons and get your seat, and that's why it's going to be higher. So it's kind of skewed. You wouldn't necessarily want to do that. So that's why that's what you would write down. And then B, what could you do to get more accurate data?
Choose a random sample.
Yeah, a random sample in all of the students, cafeteria and in the commons, okay? So use, yes, I do. Cafeteria and commons. So let's keep going. Number 30, Fred surveys 40 randomly selected upperclassmen and finds that 80% plan to go to prom. All right. There is a 4% margin of error. Find the confidence interval. So what are you supposed to do? Add and subtract the 4% from 80. So you're going to get 76% to 84%. Interpret what the numbers mean. So what does that tell you?
We expect 76 and 84% of the upperclassmen to go to prom.
Yep, we expect 76% to 40 or to 84% to go upperclassmen, sorry.
Up for
E
yeah.
to go to prom. Okay? If only 70% go, would this be surprising? And the answer is yes if it's outside of the range.
You would to explain, or just gonna say yes?
It doesn't ask you to explain.
Okay.
It just says, would this be surprising? Okay? Number 31. A researcher group wants to find out if students are more likely to turn in homework if it's on paper. Okay. You say no? Considering everything right now is digital, this is a funny question. Okay, but it's a good question because, I mean, I do have some students that would rather it be on paper, but almost everybody I have wants it on the iPad. Yeah.
I want on paper.
You want it on paper? No, that's too bad.
I'd rather have stuff on paper. I like paper more than iPads.
Whoa, I don't like paper more than iPad.
That's funny.
Easy on.
All right, Kelsey, I'm going to mail you your paper.
Wait, that doesn't work like. No,
I'll mail you the
All right, so Mr. Old School's grade book, and they see how many missing assignments there are, and Mr. Old School assigns things only on paper. He has 20% missing assignments, so that's the old way of doing it. He's got 20% missing. Mr. Young's grade book has only 10% missing. What's the explanatory variable?
Oh, paper versus iPad.
Very good. Paper versus iPad. You can say paper versus digital. That would have been okay.
Anyway,
And what is the response variable?
missing assignment.
Missing assignments. Very good.
It's like your
Yes.
Good.
Okay. Is this observational or experimental?
Observational.
Why?
The students were not randomly assigned.
Yeah, they weren't randomly assigned who was getting what and what classes they were in, so it's observational. Can you say that the iPad caused more assignments to be turned in? Or it's an association between iPad and less missing assignments? It's association.
Right.
What other factors might have caused the difference in missing assignments?
The teacher.
Yeah.
And the subject, right?
Teacher expectations,
Losing the paper.
loss of
Subject,
paper.
Subject.
Sure. Subject.
That's a great one. English is not nobody's strong suit.
actually really good
Bro,
English.
who actually likes it?
You all right on there?
The English teacher.
I like taking English.
All the English teachers are any of that.
You like
Miss
taking
Butcher
English
is
or
the
Spanish?
best. Miss Butcher is awesome.
What's that?
What?
What are you
Taking
doing?
English 'cause she hates Spanish.
Oh, nice. Very, very good.
Guys, I have a 50% English right now.
Good thing I'm not gonna send that recording out.
Pretty good.
I was 64.
Okay, last question, guys. Let's get this done. A research group wants to find out if funny ads or serious ads are more effective. They make two different ads for the same product, one funny and the other serious. They randomly choose half of their participants to show the funny ad to, and the other half get the serious ad. They find that more of the funny group bought the product. What's the explanatory variable?
Funny versus serious.
Type of ad.
Type of ad, thank you.
Bruh.
Which, that would have been okay. The type of ad is either funny or serious. Okay.
Which one of?
And what's your response variable?
Buying the product.
Buying the product. Because Kalini has the answers.
I did it last period. I didn't have anything to do in Spanish. So I
Okay.
didn't do it.
Is this observational or experimental?
It's experimental.
It's experimental because they're making this. The research group is doing this on purpose. It's not observational. They created it. They assigned it. Okay, so it's experimental. Can you say that the type of ad is caused or it's an association?
Caused.
Why is it caused, Smarty Pants?
I'm not sure.
Not sure because you just read the answer. Why is it caused?
What answer? You didn't even post the answer, did you?
Well, why are you saying it's caused then?
Hold on. I can figure it out. Don't say anything.
Kelsey? Does anybody want to tell me what they think?
It's random.
Hmm.
It's a big.
Can you say that the type of ad caused the change in how many people bought the product? Because it's experimental, meaning they made this experiment. You're not observing, they're making this. You have to assume that the result was caused. Okay? So this is a causation. Okay? Not association. Alright, so I'll send that.
Wait, don't hang up.
Did we turn this in? Wait,
Show her
what
the
was that?
board.
Yeah, turn it in.
What's the answer to that one was?
On that, show her the.
Caused.
Oh, yeah, you might need to scroll up.